In this example, we want to find the force that this bar provides. Uh, this problem is a little unique because the object that we have, this 80 kilogram object, is not in contact with the bar. So we can't necessarily find the forces on the object in order to find the force that the bar provides. Neat, slick trick, a way of doing this is to consider this point right here, my object. So what I'm going to do is I'm going to go ahead and draw a force diagram for that point right there. First force that I'm going to take a look at or take care of is the force of weight. That's downward, F of G, and that's going to be equal to 80 kilograms times 9.8 newtons per kilogram. We'll finish calculating that out in a minute. The next force I'm going to take a look at is, clean that up a bit. There we go. It's pointed downward. The next force I'm going to take a look at is the force of tension on this point in this direction. So I've got a tension force headed off in this direction here. I'll call that F of T. We don't know what that is, and we do also know that it is 20 degrees above the horizontal. And then, of course, there's the bar. Now, this bar is not pulling on this point, because if it were pulling on this point, we would think this would swing in. It's actually pushing outward on this point. Think of it this way: if I remove this bar, this whole assembly box and everything is going to collapse towards the wall, and we're going to wind up with something, like this, where that box is hanging down here against the wall. Inserting that bar causes it to be pushed outward. So the force of the bar, and call it force of B, for the bar is actually a push outward. All right, so at this point, let's go ahead and take care of calculating that force of gravity, or force of weight. So we've got 80 kilograms times 9.8, which is going to give us 784 newtons in the downward direction. So it's going to be negative when we go ahead and put it into an equation. Let's take a look at our steps. We took care of the force diagram. The next thing we want to do is rotate this if it's on a ramp. It's not, so I'm going to just cross that out. I'm not going to do that. Figuring out my components would be next, and I do have an angled force. That's this tension force. So I would break this into its components. It would be F of T in the x direction and F of T in the y direction. So those are my two components. And so we've got that taken care of. Motion in the x direction and in the y direction. This object is just hanging there. It's not doing anything. So my velocity is equal to 0, which means my change in velocity is equal to 0. Anyway, somebody else picked that up, which means that my, where was I at? Oh, I hate when phone calls distract me. Oh, I know what I was going with. That means that the sum of the forces has to equal 0 in both directions, because this is not moving at all. It's not moving horizontally. It's not moving vertically. It is not moving, which means my velocity is 0, which means my change in velocity is 0, and according to Newton's first law, that sum of the forces in both directions has to be equal to 0. So I've evaluated my motion. So now I'm ready to go ahead and take a look at the forces in both the x and the y direction. So Let's take a look at the x direction first. So sum of the forces in the x direction. I'm looking at all my horizontal arrows. I've got force of the bar plus force of tension in the x direction is going to add up to 0. And at this point, I don't know that I can figure either of these out at the moment. I don't know the force of the bar. I don't know the force of the force of tension in the x direction because I don't know the tension force yet. So let's take a look at the sum of the forces in the y direction and see if that can shed any light on this. Some of the forces in the y direction are going to be the force of weight plus the force of tension in the y direction, which is going to be equal to 0. I know the force of weight is going to be a negative 784 because it's pointed downwards. So I got a negative 784 newtons plus the force of tension in the y direction is going to equal 0. So force of tension in the y direction is going to be equal to 784 newtons in the upward direction, or positive 784. At this point, using Chief SOHCAHTOA, I can go ahead and calculate that tension force. What I'll have is I have the leg and an angle, so I can go ahead and get the hypotenuse. Let's go ahead and do that as a sidebar over here. I know that according to SOHCAHTOA, sine of 20 degrees is going to be equal to that opposite, which is force of tension in the y direction, which is going to be 784 newtons over the hypotenuse. Neaten this up again. 784 newtons over the hypotenuse, which means that I can just do some algebra here. And after I do a little algebra, I multiply both sides by the hypotenuse. So it cancels out over here. I'm going to divide both sides by sine of 20 degrees. So it cancels out over here, and I wind up with the hypotenuse is going to be equal to, or in my case, that hypotenuse is f of t, right? F of t is going to be equal to 784 newtons divided by sine 20 degrees. So let's go ahead and calculate that. I've got 784 divided by sine 20, enter, and that's going to be 2,292. So it's 2,292 newtons. So at this point, now that I know that this is 2,292 newtons, I can use that to figure out f of t in the x direction over here, and then use that to get the force of the bar. So let's see here. Ft, let's do this down here. Ft in the x direction is going to be equal to, that's the adjacent, so it's going to be cosine of 20 degrees. It's going to be 2,292 newtons times the cosine of 20 degrees, which is going to be, grab a calculator again, I already got that in there, let's do this, times 2292 times cosine 20 degrees and that's 2154. 2,154 newtons. And that's going to be in the negative direction since my force is headed to the left. So in this case, now I can go ahead and solve this. We know that the force of the bar is going to be plus a negative 2154 newtons is going to be equal to 0. So that means that the force of the bar is going to be equal to a positive 2,154 newtons. And there's my answer. The question was, find the force provided by the bar in the diagram. So that bar pushes out with a force of 2,154 newtons.